So since these limits are now x going to infinity, this is endpoint behavior, we can actually apply the strong over weak argument. So again, if we tried to algebraically simplify this, it would be a little bit difficult because this is not easy, because that root, we can't factor it very easily and stuff. But we can say that we have, in this case, a polynomial, okay, that's kind of strong, an equivalent strength polynomial on the bottom, okay. So we have the same power on the top and bottom. What we can do is say, well, at large numbers of x, large values of x, these two terms are essentially insignificant, and we can just compare 2x squared to negative 3x squared. Okay, so the limit then becomes, we can apply the limit to just the highest power ratio. So this ends up being, the limit ends up being negative 2 over 3. Okay, so 2 over negative 3, our limit just becomes negative 2 over 3. Again, we have endpoint behavior. We want to know what's happening at large values of x. Well, we have a weak function over a weak function in the denominator, although the numerator is much weaker than the denominator. So this is a situation where we have weak, in fact, the weakest function over a little bit stronger function. Although it's weak, it's still stronger than the numerator. So we have a weak over strong situation that always is going to end up going to 0. Okay, so my limit then is 0. So here we same thing. We have our linear function, we have a log function, and we have a square root function. Okay, so we have weak, a little bit stronger, a little bit weaker. Okay, so we basically can ignore this at large values of x, and we can compare this strong over weak. Okay, so we can say that this is our strong function on top. Okay, although it's not that strong, we have a weak function on the bottom. And this will always go to 0. Okay, so oops, that's not strong over weak, goes the other way, goes to infinity. Okay, so weak over strong goes to 0. Our strong over weak situation goes to infinity. So this one here is kind of tricky. Okay, so we have kind of here like an x to the power of some weak x, but the base is going to grow. Here the base is going to remain static, but the exponent is going to grow. And it's going to, although this exponent is weaker than this one, or sorry, stronger than this one, this base is stronger than this one. So it's kind of hard to tell what's going on. So we need some help with this essentially. Okay, so I've given you one here. You have x to the power of root x. Okay, it's going to give us this graph that looks like this. So I don't know what's happening at 0, but x goes to infinity. It looks like the denominator does end up outgrowing the numerator, so it tends to go to 0. So the denominator seems to be a bit stronger here. Okay, so how can we then make the argument here? Well, what's the comparison here? We know everything's the same except for this exponent here and this exponent here. We're just going to compare these two exponents. So this is going to be my argument. I know that the square root x is more powerful than 4 ln x. Okay, because I know that as x gets large, the root x is going to be always outgrow the log. Okay, no matter if I have times 4 log. Okay, so that means then, because of that, what I can say then is, for large values of x, I can say that x root x is going to be over e to the x, so the limit of that is always going to be greater than the limit as x goes to infinity of x for power 4 log x over e to the x. So this is 10, this limit is equal to 0. This is equal to 0, so this must be less than 0, which is, well, it's going to be 0 as well. Okay, less than or equal to, like that. Okay, so that's going to be equal to 0. So then my limit then, using an argument this time, okay, it's a comparison argument. This is a little bit different than what we've done before here. We're not doing any algebra. We're just doing a comparison, a logical comparison. So because of this comparison, we can say then that this limit must tend to 0, because this expression is always smaller than this one. So this one's tending towards 0. So this one will always tend towards 0 as well.